Hello everyone, this is Girish, and today we will look at one of the data point which I came across, which is titled with "World's Biggest Energy Users Are Not in the West." So it talks about which are the top 10 countries which are the biggest energy users. It is shared by US Energy Information Administration and it was published in Times of India. So we will look at that. And also, what we will do is we will look at this data to see how AI can drive the future energy requirements in terms of helping energy efficiency, energy saving, which in turn results in cost saving. So we'll look at all those factors, job opportunities also in AI, energy area, so things like that. So let's get started. So if you look at the data, this is what is published. World's biggest energy users are not in the West. So this is the 2023-24 data. And Qatar topped global per capita energy use. Then we have Singapore and Bahrain. Now, what it says is that US is not in the top 10. India was at the 118th spot and China at 41st. So basically, it shows that Qatar, Singapore, Bahrain, Iceland, UAE, Brunei, Kuwait, Trinidad and Tobago, Norway, and Canada. So we'll look at where and what energy is usually used in these countries. What is the AI solutions for them? After that, we will also look at the cross-cutting energy requirements and basically how AI can solve energy challenges in future. And also a little bit shortly, like briefly, we will touch upon the job opportunities in this area. So let's start with the data review first. So first one is Qatar, which is like roughly 215 megawatt hour per person. So they use energy mostly for desalination, which is the freshwater needs, considering their geographic location, cooling and air conditioning, because it's a desert climate, oil and gas industry operations. It requires a lot of energy for drilling, etc. Now, the AI solutions here is about AI-driven smart grids to balance demand during peak cooling, then predictive maintenance in oil and gas to reduce wastage, very critical. Then some AI models for desalination plant efficiency. The next one, let's look at Singapore, which is consuming, as per the data, 181 megawatt hour per person. Singapore mostly spends energy on urban infrastructure and dense high-rise buildings, right? That's where it is most consumed. Data center, it's a hub for finance and tech data centers. And then also air conditioning because of the tropical climate Singapore has. What are the AI solutions? So AI cooling optimization in data centers, that's one of the area. Smart energy management in high rises, all the buildings, which is very much needed. AI powered demand forecasting for power imports. Next one, let's look at Bahrain, which is 165 megawatt hour per person. They mostly use industrial zones and oil refineries similar to Qatar, and then residential cooling. AI solutions here, AI-led refinery process optimization, same with oil and energy operations. Smart cooling systems integrated with IoT sensors. Next, let's look at Iceland, which is 160 megawatt hour per person. Where and what this energy is used is heavy reliance on renewable geothermal energy, energy intensive aluminum smelting. So they have something like that, AI solutions, AI for predictive geothermal management, and optimization of smelting processes for energy efficiency. So definitely this is very interesting. Next is UAE, which is 138 megawatt hour per person. Where and what they use for it is cooling, desalination, and skyscraper energy needs. Obviously, UAE has one of the largest skyscraper, tourism and mega infrastructure projects. AI solutions here, it can be AI powered smart city management like Dubai, Abu Dhabi, intelligent water energy nexus models for desalination. Next up is Brunei, which is 118 megawatt hour per person. Oil and gas extraction, that's their major energy use. Cooling and residential consumption. AI solutions, predictive AI for oil field operations, smart residential energy monitoring. Next one is Kuwait, which is 106 megawatt hour per person. There they have fossil fuel industries which dominate, high cooling demands. Obviously, AI solution can be for energy efficient refinery management with AI demand forecasting for urban energy balance. Next up is Trinidad and Tobago, which is 106 megawatt person per person. So it's very similar to Kuwait. And there it is more of a tourism industry, tropical climate. So they definitely can leverage AI for much more demand forecasting for energy balance. Norway, next up is 99 megawatt hour per person. So this is now below 100. They use electric heating in cold climate, obviously, so they need that much more energy intensive oil production. AI solutions here, AI enabled renewable energy integration can be a very useful thing. Optimization of offshore drilling operations. Finally, it's Canada, which is 98 megawatt hour per person. Where and what energy is used? They use energy mostly for heating in harsh winters, oil sands, and industrial energy demand. AI solutions here, AI for district heating optimization, AI for emission reductions in oil sands extraction. So that's what the top 10 countries are all about. So let's look at one section called as cross-cutting energy requirements, because all the countries, no matter what, they will definitely using energy for these areas. So the first one is AI-driven smart HVAC system for cooling and heating. Now here, how AI optimizes temperature and energy use, right? So AI data analysis, real-time HVAC adjustment, energy consumption reduction, things like that. Predictive maintenance for HVAC system longevity, right? So here, performance monitoring, early anomaly detection, proactive maintenance scheduling, extended equipment lifespan. These are some of the advantages. Enhancing occupant comfort and air quality, very, very critical. So AI monitoring system, which can do that, tracks air quality, dynamic ventilation control, which ventilation and filtration, which are adjusted in real time to maintain optimal air quality. Next, let's look at AI in water desalination, as there was a common theme in some of the countries, which is using energy for water desalination, so water energy optimization, real-time process monitoring and control. So here it is about continuous parameter monitoring and track key desalination parameters, immediate process adjustment, real-time AI adjustment, improve efficiency and maintain high product, you could say water quality, reducing energy consumption and operational cost. So here AI control strategies which can be used to optimize systems components to reduce energy consumption, pump speed optimization, optimizing pump speeds lowers energy use, then membrane performance, where enhancing membrane efficiency reduces energy and operational costs. Adaptive responses to changing water demand, right? So AI-driven demand analysis, environmental factor integration, dynamic output adjustment, things like that. Next is AI for industrial process predictive maintenance and efficiency optimization. So here it is about early fault detection using AI analytics, like AI sensor data analysis, where the model processes sensor data to detect anomalies, then predictive maintenance, which is about early fault detection through AI, which can help schedule maintenance before costly breakdown happens. Minimizing downtime and optimizing production schedules, right? So, for example, maintenance forecasting, bottleneck identification, schedule optimization, resource efficiency, and sustainable operations. So here is it's about material optimization, energy conservation, sustainable production standards. Next up is AI in data centers, cooling and load distribution. So here it's about dynamic workload balancing with AI algorithms. So whether it is intelligent load distribution, performance improvement, or overheating prevention. Energy efficient cooling strategies. So for example, AI-based cooling control, energy reduction benefits, right? Obviously, optimized cooling significantly reduces energy consumption, improving reliability and reducing operational cost. So here it's about predicting system failures. AI-enabled system can forecast potential failures to prevent unexpected downtime and improve reliability. Optimizing resource allocation. So AI optimizes resource usage to enhance uptime and minimize operational cost effectively. Then we have AI for renewable integration, balancing solar, wind, and geothermal with grid demands. AI and weather data. AI leverages weather data to forecast renewable energy generation with high precision and reliability. Consumption pattern analysis. Consumption patterns helps AI predict grid demand, enabling efficient energy distribution and management. Improved grid planning. So where you can accurate forecasting by AI supports help better grid planning and integration of renewable energy resources. Real-time adjustment of energy flows. So AI-driven energy management, integration of renewables, energy storage coordination, then maximizing renewable utilization and grid stability, increasing renewable energy share. So AI optimizes renewable energy integration, boosting its contribution to the power grid efficiently, ensuring grid stability. AI monitors and balances power supply to maintain consistent and stable electricity delivery. So here is quick snapshot of future role of AI in energy. AI enhanced smart grids for real-time balancing, AI in renewable energy forecasting, AI for energy storage optimization, AI in carbon reduction across industries, AI-powered urban planning for reduced footprint, AI in policy and demand pricing. So let's quickly look at the job opportunities in this area, which is AI-driven smart HVAC systems for cooling and heating. So here, obviously, the job role will involve AI ML engineer, right? Because for creating optimization models, IoT data scientist, which is about sensor-driven analytics, energy efficiency consultant, which is about AI-driven building retrofits, then smart city solution architect. And most of the industries which will be looking for these job roles are construction, smart buildings, facility management, real estate. So for AI in water desalination, water energy optimization, here the job roles can be AI process engineer, which is about water treatment optimization, predictive maintenance analyst for desalination plants, sustainability analyst for AI-driven water energy nexus. Industries which can be looking for this is water utilities, environmental engineering, public sector smart water initiatives. So in AI for industrial process, predictive maintenance, and efficiency optimization, here the job roles can be AI and industrial IoT specialist, predictive maintenance engineer, process optimization data scientist, industrial automation engineer, and industries which will be looking for will be oil and gas, manufacturing, steel, chemicals, energy intensive industries. For AI in data centers, cooling and load distribution, here the job roles can be AI infrastructure engineer, which is about cooling optimization, cloud operations data scientist, AI system reliability engineer, which is about predictive scaling, green IT consultant. Industries which will be hiring will be cloud providers like AWS, Azure, Google GCP, telecom, fintech, e-commerce industry. In AI for renewable integration, balancing solar, wind, and geothermal with grid demands. Here the job roles will be about AI renewable energy forecaster, smart grid AI engineer, energy storage optimization specialist, grid cyber security analyst, AI enabled, things like that. Industries which will be hiring obviously renewable energy companies, utility providers, smart grid projects, government energy missions, things like that. So that is what I wanted to cover today on AI data news, and hope this information was useful. Looking forward to continue providing some information like this. Thanks again and have a nice day. Bye.